We are now recording. Let's get PowerPoint up. I thought I already had it up, but it's going down again. There it is. And we'll pick up from the current slide. Yeah. And EJ's here. What's that? Oh. Okay. All right. First thing I want to know is if you have questions on anything we've done so far. Correct ones.
There's one of them, but I just can't find it.
Which one's that?
It's number 7.
Number 7.
Yes. It's making me flustered.
Okay, let me get down in my stack to where I found it. Okay, here we go. Has everybody gotten the test? Okay. Okay, number 7. All right.
And don't try to find it in the book, because I tried to find it in the book, but I could not find it.
The thing is, we didn't do it actually, but we came close to it. This is in, I think, oops, I'm in the wrong chapter. 4.2.
It's Milwaukee.
Now, if you check in your text, let me just make sure that there's none better. On page 277, 4.2 exercise, 9 through 12 is similar to this. Not quite the same.
Those are already on the unit circle. This one isn't, so I can't figure out how to find it.
These are the ones you're used to seeing on the, all of them are on the unit circle. Yeah. Okay. But especially if you combine the ones 9 through 12 and then you go to do the ones 13 through 22, they're almost the same, aren't they? Except, again, those are ones that you're familiar with. Okay? So let's, let me get my pen activated here. Okay. This is page 277. This is 4.2 exercise. And you pick one of those, any one of them, 9 through 12 or 13 through 22. Or 23 through, I mean, you could do any of them. I'd say 9 through 12, 13 to 22, 23 to 30, any of those. Pick any one of them. We sure could. Yeah, that would be fine.
Pi tenths.
Okay. But let's do one of the others, then we'll do pi tenths. Pick one of these. 10 pi fourths. Okay. What it asked for here was, in this exercise, find the point x, y on the unit circle that corresponds to the real number t equal pi fourths. Okay. Now, that's the same as number 13, which says, evaluate, if possible, the sine, cosine, and tangent at t equal pi fourths. Okay? Well, okay, it's the same value. T is the same value, is what I mean. Okay. Now, if you were to do this one, I think I know how you would approach it. How would you do that? It's in the first quadrant. Very good. And pi tenths will be in the first quadrant too, by the way. Okay? So, how would you proceed? Okay. Very good. And the values would be root 2 over 2, root 2 over 2. Okay. Now, if we were to do number 13, and by the way, this is the y value, this is the x value, right? Okay. Just want to make sure. And on number 13, when it says, evaluate, if possible, the sine, cosine, and tangent. So let's do 13 too. What is the sine of that t equal pi fourths? Okay, yeah, that was very good. Why is it root 2 over 2? The y value, very good. That's what I was going for. So basically, this is sine of t, right? And this one would be cosine t. Okay? Now, there was nothing on the test that said you couldn't use your calculator, right? And we're looking for the points x, y on the unit circle corresponding to the real number t is equal to pi fifths. Okay? Couldn't you get the x value by doing that and the y value by doing that? Because notice it said round your answer to one decimal place. So it's not looking for a root 2 over 2 or a root 3 over 2 or something like that. It's looking for just the number. Isn't it doable? You want to do it? You want to do it for pi tenths? Okay, let's do it for pi tenths. Okay, t equal pi tenths. How would you do that? What would be the x, y value? That's all we're looking for. X, y. To the nearest decimal point.
Well, I guess change the pi tenths maybe to a 3.
You could do that, but that's extra work. You got a calculator, right? Okay. It'll take radian mode, won't it? Okay. So just do get in radian mode and do the what's that?
Sine is 0.172.
And where does this go? Okay, and it's 0 point what? 17. Well, it only needed 2, so 0.2. And what was the x value? Okay, let's do it 0.98 what? Okay, let's do 98, because if you round to 0.9, you'll get 1.0, and that's not quite right. So let's do 2. Oh, you don't have a pi key? Oh, okay. Well then, yeah, you. Okay. Yeah, okay. Oh. Because on the unit circle, because the radius is 1, hypotenuse is 1, r is 1, whatever you want to call it is 1, then the x value is going to be the cosine of the angle, and the y value is the sine of the angle. Okay.
I don't appreciate that, because I was like, man, I had the radians, like, I gotta know it.
And you knew it. Just didn't know you knew it. Okay. Okay. Now that's not the answer that's on your test. That's not the question on your test. For pi tenths. Did you do cosine of pi tenths? We'll give you this, sine of pi tenths gives you that. And this is Orlando, right? All right, we're getting there. It says to the nearest decimal, 1 decimal place, round to 1 decimal place. And I rounded this to 2 because if you rounded that to 1, it'd be 1.0. And that's not, see, pi tenths is so small, you're close to 1 for cosine. So I said, let me do 0.98. The one in the pi fifths is going to be easily rounded to 1 decimal place. And that's from cosine times pi over 10? Pi tenths, right. You don't get that? Oh. Oh. I can't read it. So 0.9, yeah, 0.95. That it sounded reasonable. I thought this one seemed a little big, but maybe it's not. But yeah. Okay, I see. Okay.
I changed to a negative this time because I changed it from degrees to radians.
Okay. Okay. Start over in radian mode and do it that way.
I got a negative cosine.
Of pi tenths?
That shouldn't be negative though.
No. Okay. I need to watch you do that. Okay.
Look. We have pi divided by 10. Okay. And then, cosine. Yep, we use the radian.
Oh, there's it. Okay. See, what it's doing, I think, is doing the cosine of 10. It's doing just the thing right in front of it. If you put pi over pi divided by 10 in parentheses. All right. These little black boxes or white boxes or gray boxes or whatever, they mess you up every time, don't they? Okay. All right. Any other questions before we get started on today? This is a question referencing question 7 on your test. Any others? All right. 20. Okay, did you find one like it in the text? Okay, wait until I put it away and then you ask. Okay, let's see. Okay. This would have been, whoa, one wrong way. Okay. What's that? Oh. I really regret this, but there's nothing I can do with it. But this is so incredibly similar to on page 298, example 102.
Number 20?
Yeah.
What page?
298, number 102. That wasn't one you had for homework because it's an even problem. But that is scaringly similar.
It's only one.
Okay. So since it's in the book, I will do it. With under protest, though. Okay.
I think we choose number 102 for you to do.
What's that?
I think we choose number 102 for you to do.
Okay. So the current. Ooh, I thought that erased it, didn't it? There we go. The current I in amperes, when 100 volts is applied to a circuit, is given by I is equal to 5 e to the minus 2t times the sine of t. Does that look familiar? Okay, where t is the time in seconds after the voltage is applied, approximate the current at t equal 0.7 seconds after the voltage is applied. What do? You plug in. I is equal to 5 e to the minus 2 times 0.7 times the sine of 0.7. Okay? Now, what mode do you need to be in? Radian. You don't see any degree symbols anywhere. Radian mode. And you just do the math. 5 e to the minus 1.4 times the sine of 0.7. Okay. Now, the only thing to watch out for is be sure you close parentheses at the right places. Because I think when you go to the E, it automatically opens for you, doesn't it? You don't have an E key? By the way, I know in my book they have answers to all the checkpoints in the back. Does your book have those? What is this, 4.4? All right, the drawings here. We're just missing James, Jasmine, and Kamari. Yes, ma'am. 10:45 until 12:30.
I got 0.7.
0.79 amperes. Yeah, that's good. Yeah. Whoops, wrong pen. 0.79 amperes. Measured in ounce. Current is measured in ounce. Okay. Any questions on that? Okay. Are most of the problems calculator problems, or are they other kinds of problems? What's that? All right. Any others? By the way, you're probably not too interested in this, but I'll explain what's going on here. This is a current that's being damped pretty quickly. Normally you think of this as your amplitude, but you see the whole thing is your amplitude. It has a variable amplitude, and that amplitude is decreasing over time because e to the minus, the bigger the number gets, the more it's damped. So this is a current that's doing this.
Is there an A at the end of that?
What's that?
Is that an A at the end of that?
Is it a what?
An A
Where?
at the end of your answer.
Yeah, amperes. Yeah. Yes.
I didn't
Current.
know if
Yeah.
there's supposed to be any units like
Well,
after
they say that in the book, the current I in amperes. I don't know if it says it on the test. And the symbol for amperes is capital A, because it was named after Louis Ampere. Okay, he's the one who did some of the early work in electrical current, so they named the unit after him. That's why it's capitalized. All right. All right. Any other questions? Is this making sense? All right. Let's go back where we were. Ready to start again? Okay. I'll answer any questions anytime. So where we left off last time, top of page 303, section 4.5, translations of sines and cosine curves. Now, if you remember, we started off with, this is exactly the opposite of how we did it in Math 112. Math 112, you started off with your shifts, and then you went to your stretches and strings. This time we started with stretches and strings, and now we're moving to the shifts, or they're calling it translations of sine and cosine curves. Now, if you remember our original equation, not quite, they've left one off. The constant c in this equation, now I don't like the way they write this. The book has it this way, so get used to it, but I like to write it a different way. It makes it seem more like what we did back in Math 112. In fact, in everything in physics, it makes more sense the other way. The y is equal to a sine bx plus or minus some c. Or y is equal to a cosine bx plus or minus c. Okay? What did the a do for us? What was it related to? The what? Okay. And what feature of the curve did that relate to? Okay, very good. And we called that on the curve. It starts with the same letter. Only you usually capitalize it. Amplitude. Okay? A relates to the amplitude. It's not the same as the amplitude. Sometimes it is, but the absolute value of A is the amplitude. B related to what? To what? B related to what? Oh, it was so long ago. Last Thursday. Say again? You may be.
I said stretch.
Okay, it is a horizontal stretch or a shrink. What feature of the sine curve does that affect? The B. The A affects the amplitude. See, a sine by itself is going to stay between plus or minus 1. You multiply it by A. If that A is big, you may be plus or minus 10 or 2 or 3 or 4/5 or something like that. Or if it's shrinking, it's 0.1 or 0.7 or something like that. What does the B affect on the sine curve? Horizontal. And what is it that repeats itself horizontally? The period. B relates to the period. How does B relate to the period? What is the period? If you know B, do you know the period? What's the normal period for a sine function or a cosine function? 2 pi. So guess what? The 2 pi is involved with it. What's the period of one that has a b in front of it? 2 pi divided by b. Exactly. That gives you the period. A is related to the amplitude. Absolute value of A is the amplitude. B is related to the period. 2 pi divided by b. B is the period. Now what the C does, if you'll notice, the C is affecting the X here by plus or minus, okay? And that's your shift. Which kind of shift? Horizontal shift. And in electronics and things like this, in physics, it's often called a phase shift. So horizontal translation or horizontal shift, we called it in Math 112, but quite often it's called a phase shift here of the basic sine and cosine. That's what the C does for you. A affects the amplitude, how far above or below equilibrium it's going. The B affects the period, whether it's stretched or shrunk, whatever. The C is a translation or a shift in the sine or cosine curve. So comparing y is equal to A sine bx with y is equal to A sine bx minus c, and this is where the way they do it gets really strange. I mean, it's perfectly fine to do it this way. The bx minus c goes from 0 to 2 pi. Whatever is in here is going from 0 to 2 pi. Okay? Since the b is involved with it, the period's involved with it. Okay? Then you solve this for x, and now you get what x is going from, and that involves also the shift of the c. Now, it's perfectly fine to do it that way, but let me show you the way I'm used to doing it, and to me it makes more sense. Maybe to you it won't. Okay? Since you deal with the phase shift, with the period with B, I like to write this way. Y is equal to A sine. Now, let's imagine those numbers aren't there. B times X, and then I'll say plus or minus c, okay? That to me makes more sense because this then is going to give you the shift first, and then you multiply by b to get the amplitude, stretch or shrink. And that makes more sense to me, okay? Now the book doesn't do it this way, and my c and their c aren't the same, but they're related to each other, okay? But this is how we would do it in electronics or in physics and other things. You would typically do that. Y is equal to A cosine B times X plus or minus C, okay? And that way you separate the phase shift from the period. This way they're mixed together, okay? The B is in there, but the C is in there, but the C has a B in one. And you'll see, in fact, when you solve this for this one right here for X, you get X equal C over B. And this is X equal 2 pi plus C over B, okay? So it's just really confounding the issue here, okay? And this is, then they split that up. So it's going from C over B to C over B plus 2 pi over B. Well, that's the period. This is your phase shift. See, you got the B's tied up with it. That's your phase shift, okay? Is where you're starting, C over B. Where if you did it the other way, factor out the B first, then the C would be your phase shift. So, but the book does it this way. If you like doing it this way, do it this way. It's perfectly fine, okay? So this implies that the period of Y starts at this point and ends at this point. This being one period later. So it's this plus that. So yeah, that's the right endpoint. So it's shifted by amount C over B. So the number C over B is called the phase shift. Now what I like to do is factor out the B to begin with, and then what's left, that's the phase shift, not a ratio, but the actual number, okay? Either way you want to do it, okay? So the graphs of Y is equal to A sine B over C, and again, I would never write it that way. I'd factor out the B and then do that. You know, A cosine BC, BX minus C, have the following characteristics. Assume that B is always positive, not zero, not negative, okay? The amplitude, absolute value of A, the period is 2 pi over B, and if you had factored the B out, then and what was left with the X, that would be your phase shift. So the left and right endpoints of one cycle would be determined by solving these equations, which is a pain in the neck. Well, it's not that hard to do, but it just is, to me, is extra work. If you just factor out the B to begin with, then whatever you have left, that's your phase shift. Okay, which is exactly what they're doing, but they're having to do it twice, where if you just do it to begin with, you got it not. So let's do this one, okay? And I'll let you choose whether you want to do it the book's way or my way. I don't care. It says sketch the graph of that function. Okay? I think we all identify our parameters first. Well, the first thing you notice here. Okay, A is -3. What is that related to? Amplitude. So what's your amplitude? Is 3. Absolutely right. Okay. Now here's what I like to do. The book doesn't do it this way, but this is what I like to do. I like to factor out the coefficient of X. So this will be -3 times the cosine of, factor out the 2 pi. And what's left? X plus 2. Isn't it? Now, if you do it that way, and then think back of what we did before, this is your A, This is the B, and that's what they're going to call the B. But this is what I call C. They call it this over that. But that is exactly what we've got here. That's the phase shift. This is your A. If you do it my way, A, B, C. A relates to the amplitude, B relates to the period, C relates to is the phase shift. What's that? Okay, factor out 2 pi. And what you have left is 2 pi into x would be x. 2 pi into 2 pi x would be x. 2 pi into 4 pi would be 2. And that gives it to you. Now, the other thing to remember, everything that deals with the x, think backwards. What is your phase shift here? I'll give you a hint. It's not 2. -2, because it's always backwards. Okay? So, your amplitude is this. Your period. Wait, okay. What do you call the 2 pi? That's your B. B is equal to 2 pi. What is that related to? What do you put at the end of a sentence? Period. Okay. Goodness, this is pulling teeth here. What is your period? 2 pi over B. So it's 2 pi over B always, but your B happens to be 2 pi, so it's 2 pi over 2 pi, which is 1. So your period is 1. And your phase shift, or horizontal shift, is what? Okay, let me go back a minute. Probably rushing this too much. Okay, your third parameter here is C. What is your C? Now this isn't the same C the book calls it. What is your C? -2, and that is your phase shift. Your phase shift is -2. All right, so we're going to start our graph. Okay. Now what does the amplitude determine on how you graph? Yeah, for vertical. You got to go up to at least 3 and down to at least -3. So let's do 1, 2, 3, 1, 2, 3. 1, 2, 3, -1, -2, -3. Okay, got that. Now, where I go next for the horizontal, start with the phase shift. Okay, you got, okay, let me back off a little bit. Let's go back to the period. What do we do with the period? This was last week. I know it's a long time ago, so what do we do with the period? How do we use it? It's the first thing we do to it. Okay? Go back to example 3, the previous page. The amplitude is what? This is in the solution for example 3. The amplitude is 1. Moreover, because B is equal to 1/2, the period is 2 pi over B, which is 4 pi. And then what's the next sentence? Divide the period into 4 equal parts. So once you get the period, divide it by 4. So what is 1 divided by 4? 1/4. Okay, hang on to that. Those are going to be my tick marks. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4. Okay, over here, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, and so on. Okay, so you need to have, that's what that, you get the period, immediately divide by 4. Okay, so this is -1/4, -1/2, -3/4, -1. I'm going to do every one now. 1, 2, 3, -2. Okay, 1/4, 1/2, 3/4, 1. 1, 2, 3, 2. Okay. There's a reason for that. Because what's your phase shift? -2. Way over here. That's where you start. Now, where does cosine normally start? At 1. Except your amplitude, your thing multiplied by the cosine here is a -3. So rather than starting at 1, you start at -3. So it starts down here at -3. Okay? That's what the A does for you. That would be starting at 1. At the phase shift. Okay? The phase shift tells you where to begin. Runners, swimmers, take your mark. Runners, take your mark. That's your mark. You start at the phase shift. And where does it normally begin? Cosine normally begins at 1. But you take that 1 and multiply it by -3, so it's starting at -3. And then, here's why you did the quarter of the period. It goes up to 0, up to +3, down to 0, down to -3, up to 0, up to +3, down to 0, down to -3, up to 0, up to +3, down to 0, down to -3, up to 0. You just do this ad nauseum, okay? All right. I could have continued back here. 0, +3, 0. And Kamari gracious us with his presence. Good deal. All right. So we're just missing Jasmine and James, the 2 J's. Okay. All right. 2 of the J's. Do we have any other J's? Nothing. That's it. All right. And then you connect the dots. Yes. Okay, yeah. Okay, normally cosine begins where? At 1. Okay. So, okay, now let's start over again. All right. We determined the amplitude. A was -3, the amplitude 3. We factored out the coefficient for x, 2 pi. That was our B. B is related to period because the period is always 2 pi divided by B. This B happened to be 2 pi, so that gave you 2 pi divided by 2 pi is 1. So your period is 1. You're going to complete 1 cycle in 1 unit. So that's why I had to spread out here. We divide that period into 4, and that gave us 1/4. Okay? If you factor out that B, what you have left is x plus or minus c. Well, actually, it's x minus c, but because it's a plus there, that makes c a -2. That's your phase shift. That's where you begin. You don't begin at 0 now. If you have a phase shift, you come back to -2 to begin. Okay? Now, where does cosine usually begin? At 1. But that's being multiplied by -3. So what would have been a +1 is multiplied by -3. So that's where you start down here. And then from here, this is why we did it every quarter of a period. You step through it. Going up and down, up and down, up and down. Okay? So that enables you to draw sort of your curve here. Pretty ugly curve, that. And if you agree, you lose points. Okay. Okay. There's your curve. Now, you actually started here. Can you tell that? That is exactly 2 periods to the left of here. So it looks like you're starting right there. Okay? But it is. It's a phase shift here, but it's exactly 2 periods. So from -2, -1, 0, you're right back where you started. So that just looks like that would have been the same if this had been 0. It would have looked just like this, the same, without a phase shift, because the phase shift was exactly 2 periods. But we did it the way they said. Does that make sense? So identify your A, that gives you your amplitude. Factor out the B, that's what I do. Okay? And That gives you the period, using this formula always. And then what you got left here, that's x minus c, that is your phase shift. Okay? Your horizontal shift. Translation horizontally. That was c equals minus 2. So that moved you, when you get the period, divide it by 4. That tells you how many tick marks to put in there and how to scale this. Now, obviously, this isn't scaled very well because this is 3 here and this is 3 there, So obviously, it's not scaled. But I did it so you could draw it and see everything. Okay. All right. That's how we did it. You want to see how they did, or y'all still writing? Okay. Yes. Oh, you're through? Man, fantastic. Now remember, folks, was today the day? Wow, you got it all done. Where'd you go? Actually, in my morning class, they had a quiz technically due today. Some of them were turning it in with blanks on it. I said, look, I'd much rather you fill in the blank and get a better score than turn it in. Now, just get it to me as soon as you can, but don't. So, and that's the same way with you. I don't want you turning in blanks. I want you figuring out answers. That's the learning process. The test is just a part of the learning process. Okay? Not just measuring how much you've learned, but hopefully helping you learn it. I'd prefer that. That way I can give partial credit. I love giving partial credit, but with no work, no credit. Okay? Okay. So yeah, I love to see your work. If I see you got a wrong answer, maybe I can figure out where you got messed up. That may help you later. But if all I got is the wrong answer, it's just wrong. I can't give you much partial credit. Okay? Can I move on with this one now? No. Huh? Okay. Well, it's up to you. You don't have to turn it in. If you're very confident you got it right, I won't need to see your work. Okay. Goodness, where is that? You know, I realized just now, this example, they skipped example 4. Yeah, that's where I messed up. Okay? This is example 5. We shouldn't have done that one yet. Let's back up and do example 4. Y'all okay? Anyone else need this any longer? Okay. They skipped example 4. It caught me by surprise. Okay? Let me erase all this and we're going to do example 4. We should have done example 4 first. Okay, this is example 5. Let's do example 4. Analyze the graph of this. Y is equal to 1/2 the sine of x minus pi thirds. Where would we begin? Say again? A. What is your A? What does that relate to? And what's your amplitude? Yeah, but what is the value of it? One half. It's the absolute value of 1/2, which is 1/2. Okay. Now, what's the next parameter we look for? B. What's your B here? Say again? If you don't see a coefficient, you understand it to be 1. And what does that relate to? Period, okay? Final, okay? And how does it relate to period? The period is? Okay, what's the period, the definition for it? 2 pi over b. But your b is 1, so what's your period? 2 pi. 2 pi divided by 1 is 2 pi. So this is a regular old sine curve, period 2 pi. And then finally, what's your C? Pi thirds. It's the minus, it's whatever follows the x minus whatever. If that had been a plus, it would have been a minus pi thirds. If it's a minus, or it's a plus pi thirds. Remember, whatever's dealing with x is backwards. Okay? So that's pi thirds. Oh, what were you supposed to do with the period once you got the period? Divide it by 4. So 2 pi divided by 4 is pi halves. Okay. Now here we have a problem, Houston. Our interval here needs to be in half pi's, but our offset, which is our phase shift, is pi thirds. And by the way, C is, when you do it this way, the C is the phase shift. Okay? It's pi thirds. So unfortunately, now on this one, I need to have my tick marks in sixths of pi's, because you have to be able to mark out pi thirds, but also pi halves. So the least common denominator there is 6. So those are going to be my tick marks. Okay? Let me see if I can squeeze it in here. Okay. Now, where do you want to begin? Vertical or horizontal? I don't care. Second? Horizontal. Okay? I just said my tick marks have to be in sixths, because we have to have both the third pi's and half pi's in there. So that's going to be 1 6 pi, 2 6 pi, 3 6 pi, 4 6 pi, 5 6 pi, 6 6 pi, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? How about vertical? What do I have to run between? Say again? Yes, it has to be plus or minus 1/2. So I'm going to put them up here just to get it. That's minus 1/2, positive 1/2. You get to scale it any way you want to. Maybe that's a little excessive. So let's put my scales down here. This is pi 6, pi thirds, pi halves, 2/3 pi, 5 6 pi. You don't have to do all these. 1. Okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2. Okay? Minus pi 6. Minus pi halves. Minus pi thirds. Pi thirds. Minus pi halves. And 1, 2, 3. Minus 1. 1, 2, 3, 4, 5, 6. Minus 2. 2, 3, 4. Yeah, somewhere out there. Okay. You get the general idea, right? Where do we begin? Always start at the phase shift, which is pi thirds. Positive pi thirds. So this is where we're beginning. What's our function here? What's the function? The sine. Where does sine usually begin? At 0. So at pi thirds, we're going to have a 0. And where does sine go from there? Where does sine go from there? Up to plus 1, right? Okay, now we have to do another timeout, okay? Our tick marks are the pi halves. In 6, that's 3 6 pi, right? So you're starting at 1/3 pi, so 1, 2, 3, that's going to be at plus 1/2. 1, 2, 3, that's down at 0. 1, 2, 3 at minus pi halves, 1/2. 1, 2, 3 back at 0. That's how our function's going now. Because your quarter of your period is pi halves. Those are going to be our tick marks, okay? So counting backwards, 1, 2, 3, that's going to be minus pi halves. 1, 2, 3, back to 0. 1, 2, 3, up to plus 1 half. 1, 2, 3, down to 0 again. 1, 2, 3, this is going sort of wacky here, isn't it? 1, 2, 3, back to 0. So basically, here is our, I obviously didn't get my spacing right, but that, yeah, I've got these two tight and these two broad. That's what it looks like. Okay? Identify your parameters. A is 1/2, that's related to amplitude, which is 1/2. Where you go plus or minus that on the y scale. Okay? The B is 1. That's related to the period, which is 2 pi over V, which is just 2 pi. That's your period, 2 pi. And if you'll notice here from, by the way, this is pi here and 2 pi. Sort of sloppy there. Okay. Okay, so your one period, this is starting at pi thirds, it should be ending at pi thirds or 2 tick marks past your 2 pi. And sure enough, where it's in. Yeah. And 2 pi back here, which is 2 tick marks before here. Yeah, there's your period. Okay, it's repeating itself every 2 pi. But you're having to do this in the common denominator between pi thirds and pi halves is pi 6. So your offset is 2/6 pi, and your quarter of a period is 3/6 pi. So from here you count 3/6 pi. 1, 2, 3, there. 1, 2, 3, there. 1, 2, 3, there. 1, 2, 3, there. Backwards. 1, 2, 3. 1, 2, 3, there. 1, 2, 3, there. 1, 2, 3, there. 1, 2, 3, there. It should have come through here. There. And then you fit your curve in. Or you found this really scintillating, didn't you? Okay. All right. Does that make sense? That's the one they did in the book. They skipped on the slide set. So you can look at what they did, and wow, not quite as pretty a picture as mine, but real close to it. See how it works? And this was set up A, B, C. There's a minus there, so you're right there. Start with the C, then the function, where is the suction at the starting point? It happened to be 0, and then you go up and down from there. Make sense? Not quite. Any questions? All right. So that was example 4. We've already done example 5, and you see in the book, I've already erased it. Well, actually, I erased what I did. Let's see what they do. For example 5. Amplitude 3. Period is 2 pi over 2 pi, 1. And then they throw through solving the equations. If you just factor out the B, what's left is your C. They go through solving the equations and doing all that. So that gives you your interval. If you just factor out the B, it gave you the C, and you go from there. But either way you do it is fine. Both of them work. Okay? And then dividing the, I think you should have done it back here when you got the period of 1. There you divide it by 1/4. They waited till way over here to divide by 1/4. Okay? Dividing the interval, this interval, the first interval, into 4 equal parts produces the key points. And cosine starts usually at 1, but because the coefficient is -3, you start at -3. So -3 is there, and 1 divided by 4 is 1/4. So if you add 1/4 to -2, you get -7/4. cosine goes up to 0 there. At another 1/4, you get -3/2. You're up to +3 then. And then at another 1/4, and you're at -5/4. Yeah, I do this in my head, right? No. I tick them off on the scale so I don't have to worry about what the values are. That's back down to 0. And then you just keep going. The next one would be -1. Subtract 1/4 from this, you get -1. You're back down to -3. So there's your curve. Actually, drawing them is so much easier than having to calculate them like this, I think. Okay? Any questions? Any? Okay. So what we've done so far, A was related to amplitude, B related to, C is related to phase shift, which is your horizontal shift. Your D then, oh wait, here's the graph of it. Yeah, and we had already done that. Notice the -2, what they don't show, each of these is a quarter. 0, -1/4, 2/4, 3/4, 4/4 down here. 5/4, 6/4, 7/4, 8/4 down there. So yeah, there's one period of that one, which looks exactly like here, you know, so you could have started here and gone there, you know, because the phase shift is exactly 2 periods over. So that was how that one looked, if you think back. Okay. So the final type of transformation then is the vertical translation. And why in the world don't they do the plus D down here? Why do they put it in front? I don't know. But it can go anywhere. Not in the middle of this, but anywhere beforehand. So what's that going to do? A vertical shift. Up or down depending on the sign of D. The shift D units up for D greater than 0 and D units down for D less than 0. If that's a minus number, it's going down. Positive number is going up. In other words, the graph oscillates about a horizontal line, y is equal to D rather than the x-axis. So what the D says is where your equilibrium is. So far, all of ours have been plus or minus the horizontal, the x-axis. But if you got a D here, that shifts everything up here. Say if that was a 5, rather than starting here, you're starting at 5, and then you're going up and down from 5. Okay. So, where does that put us? We will now start with, I'll do this a little bit differently. I'll start at my phase shift as my x coordinate, and D is going to be my y coordinate. There's where we'll start, and then we'll go up or down from there. Okay, let's see if they, oh, that's not fair, is it? They didn't do an example with this one either. So let's do example 6. Is that going to be the best one? Or? Okay, let's do it right here. Let's do example 6 here. Sketch the graph of y is equal to 2 plus 3 cosine 2x. Okay? Where do you begin? Where do you begin? A. What's your A? Say again? A little louder. Where do you see a 5 on there? Say again? I couldn't hear. No, 3. The A is what precedes the function. Yeah. A is equal to 3. What does that relate to? And the amplitude is? 3 also, the absolute value of A. Okay. What's your B in this one? What's your B? B is equal to 2. What does B relate to? Okay, it's the period. And the period is 2 pi divided by B, which is 2, which is pi. And then what do we do with that period? Divide by 4. So our intervals, that's what I'm going to call it, interval, is going to be pi force. Okay? The period is pi, the interval pi force. What's the next one? C. Zero. There is no horizontal phase shift. Okay? And then finally, D is your vertical phase shift. 2. Going to shift you up by 2. So, I think we're able to get started here. But now we have to worry. Not worry, but just be aware of what we're dealing with here. The amplitude 3, that's how high you're going to go above or below your equilibrium. Your equilibrium, though, is going to be at 2. So I'm going to have to go at least 5 up, right? And minus 1 down. So that's going to be my vertical. Let's do minus 1, 1, 2, 3, 4, 5. Okay. Now, my interval, pi quarters, there is no phase shift, so we're going to need quarter pies. Let's do 1 quarter, 2 quarter, 3 quarter, 4 quarter, 5 quarter, 6 quarter, 7 quarter, 8 quarter, 9 quarter. Minus 1 quarter, 2 quarter, 3 quarter, 4 quarter, 5 quarter, 6 quarter, 7 quarter, 8 quarter, 9. Okay. So this is minus pi force, minus pi halves, minus pi, minus 2 pi, pi force, pi halves, pi, 2 pi. Okay. Now, phase shift is 0, so I'm not moving anywhere there. But my D2, that means this is my new equilibrium point. I'm going to draw a dotted line in there. That's my new equilibrium point. I'm going up or down from there, right? Now, it's a cosine function. Where does it begin? Normally 1. But we have a amplitude of 3. So from here we're going up 3. 1, 2, 3. So this is where we began at 0, 5. Because cosine starts at the plus 1, but you multiply by 3 with the amplitude. So, and then your phase shift, not phase shift, vertical shift is up 2. So we're starting at 5. Then every interval we come down. The interval, we would be coming down to 0, but we come down to 2. Okay? And then the next one we go down to your minus 1, because this is the lower part of your amplitude. And then here we go back to 0. Here we go back to 5. Back to 0. Back to minus 1. Back, not 0, 2. Okay? Your equilibrium. Whoops. Sorry about that. That line is just a separator. Okay. There. And then we're back up here again and down to here. And keeps on trucking. Going in this direction, we come down to our equilibrium. We go down to minus 1. We go back to equilibrium. Back to plus 5. Wait, I'm lost. Here we are. There. Back to equilibrium. Back to minus 1. Back to equilibrium. Back to plus 5. Back to equilibrium. Back to minus 1. Back to equilibrium. So here's how we're going here. Somehow, looks like I just feel like my 5s are too high and my minus 1 too low. I think my scale isn't good. But that's what we've got. Okay? The vertical shift, the D here, moves your 0 up to 2. Okay? It's a vertical shift. Everything gets moved up. That's now your equilibrium. has an amplitude of 3, meaning it's going 3 above that and 3 below this, okay? Your B is 2, which makes your period pi, which makes your interval pi quarters. So that's going to define your key points. Max, they call them zeros, they're no longer zeros, they're our 2s, min, 2, max, 2, min, 2, max, like that. And same thing going backwards. Does that make sense? You started at the first maximum because it was a cosine function and you didn't have a horizontal phase shift. Your C was 0. All right. By the way, there is a checkpoint. Well worth doing the checkpoint because you can always use the audio-video solution. Now, I asked you earlier, I didn't hear an answer. Do y'all have your checkpoint answers in the back of your book? I know mine does, but I've got a teacher's edition, so I don't know if that's just for me or if it's for y'all too. Are checkpoint answers there or just the odd number answers? My book has a checkpoint, yours doesn't. All right. Sorry, that's too bad. But you can go to the audio-video thing at watersonprecalculus.com and you can see your checkpoints there. All right, we did do example 6. We didn't get into modeling. Okay, we'll have to do that next time. Mathematical modeling. Pretty interesting problem. We'll do that next time and pick up from there. So we'll see you Thursday, right? Keep working on the test if you haven't finished, and we'll move from there. 4.5.